So good morning, students. So today we will start up with the first chapter of chemistry for NCRT class 10th CBSE, that is chemical reactions and equations. So in this video, we will first discuss the theory of it, and in the next video, we will discuss the problems related to this chapter. So we will go through a line by line process. Every line I am going to read, and then I am going to explain you so that you are very much thorough in the theory. Okay, so let us start it. So coming to the first chapter, chemical reactions and equations. So consider the following situations of daily life and think what happens when milk is left at room temperatures during summers. Iron tawa or pan or a nail is left exposed to humid atmosphere. Grapes get fermented. Food is cooked. Food gets digested in our body. We respire. So you can see that these are some processes that are occurring in the nature. So you might have seen that when you leave milk at room temperature during summer, after some time, lactic acid starts producing in it and it turns out to be curd. So we'll see some of other things like an iron nail. When you expose it to humid temperature, you will see that it is going to get rusted because of the formation of iron oxide. Grapes getting fermented is one more reaction where an acid is formed, citric acid. Food is cooked. Food gets digested in our body. So we have a complete chapter on digestion, on what happens when food is getting digested, how the carbohydrates are digested, what about the proteins, everything is there in, and what about the fats and everything is there in the chapter related to digestion. So basically, these are some physical and chemical processes that are occurring in nature. So we'll see how we have classified these chemical reactions and we'll study in detail about each of these reactions. In all the above situations, the nature and identity of the initial substance has somewhat changed. We have already learned about physical and chemical changes of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. You may perhaps be wondering as to what is actually meant by a chemical reaction. How do we know that a chemical reaction has taken place? Let us perform some activities to find the answer to these questions. So what are we talking about now? We are talking about how we will know that a chemical reaction has taken place indeed. Okay, if I want to know whether a chemical reaction has taken place or not, I want to know about it, then how will I know it? So generally, we can say that a chemical reaction has occurred when initially you have one substance and finally you have a new substance. See, if ice is getting melted and it is turning to water, is it a chemical reaction? No, it is just a physical change. It is a state change, change of state. Okay, it is not a chemical reaction because no new substance has been formed. But if I tell that carbon has combined with oxygen to give you carbon dioxide, then a new substance is formed, right? So we can say that a chemical reaction is occurred. So that is how you differentiate between a physical change and a chemical reaction. Okay, anyways, we have some activities which we can do to understand a chemical reaction in a better way. First activity is like to clean a magnesium ribbon, which is about 3 to 4 centimeter long by rubbing it with a sandpaper, then holding it with a tongs. Basically, you're burning that magnesium ribbon. So when do you burn a magnesium ribbon? What happens? So we'll see that burning of a magnesium ribbon in air. So you will have observed that magnesium ribbon burns with a dazzling white flame and changes into white powder. So what is this powder? It is magnesium oxide, Mg plus O2. Then you may ask me, we are just burning magnesium. Where is the oxygen? Oxygen is in the air. Okay. So oxygen is in the air. So magnesium plus oxygen are reacting and then magnesium oxide is formed. It is formed with the reaction between magnesium and oxygen present in the air. Second activity. Take lead nitrate solution in a test tube. Add potassium iodide. Lead nitrate plus potassium iodide. PbNO3 plus Ki will give you water. So you will see it is a double displacement reaction. Lead iodide and potassium nitrate is formed. Take one more reaction. Take a few zinc granules in a flask. Add dilute hydrochloric acid or sulfuric acid. Remember this very standard reaction. Metal plus acid. What happens? Salt plus hydrogen. Again, I will repeat you very standard reaction. This is true with any metal and any acid. Most of it. Metal. What is the metal? zinc, magnesium, sodium, these are the metals. Acid, what is an acid? Hydrochloric acid, sulfuric acid, nitric acid, okay? Acetic acid, these are the acids. So when you react these two entities, you will get a salt and hydrogen. For example, zinc I am reacting with HCl. What are the products I will get? Zinc chloride plus hydrogen. Okay. Yeah. So these all are chemical changes. So now he is telling to test the temperature of the flask in which we have reacted zinc and hydrochloric acid. So you will see a change in temperature. Okay. So why we are noting these points is that in a chemical reaction, how will I know that a chemical reaction are occurred? So we have some factors based on which we can tell, okay, yes, chemical reaction has occurred. What are those factors? So from the above three activities, we can see that any of the following observations helps us to determine whether a chemical reaction has taken place. What are that? If there is a change in state, if there is a change in color, if there is an evolution of gas, or if there is a change in temperature, then we can say that a chemical reaction has occurred. Okay. So evolution of gas, what was an example? We saw that hydrogen gas was evolved. Change in temperature is there. Suddenly you will feel that the flask has cooled down or the flask has got heated up. Okay. And there is some change in color or there is a change in state. As we observe the changes around us, we can say that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and their symbolic representations in this chapter. Okay. So now first we'll come out to what is a chemical equation then. So in the activity 1, which we discussed, a magnesium ribbon was burnt in oxygen. What it got? What was the final result? It got converted into magnesium oxide. This description of a chemical reaction in a sentence form, suppose if I'm telling that when a magnesium ribbon is burnt in oxygen to get magnesium oxide, it is a big lengthy. We want it to be a short form because you will see in that future they will have very, very complex reaction and each of them rating in this language manner gets difficult. So we introduce the symbol form for it. Okay, we'll see how it was changed to a word equation initially, simplest way. So word equation, if you see, magnesium plus oxygen is giving you magnesium oxide. Okay, better. Is better, I would say, not best, but I would say it is better. So that substances that undergo a chemical reaction, magnesium and oxygen, what are that are on the left side of the equation you 1.1? They are called the reactants. What is there on the right side? That is magnesium oxide, if you are seeing product. Okay, it has been clearly labeled. So the new substance is magnesium oxide is formed during the reaction as a product. Okay. So a word equation shows change of reactants to produce through an arrow placed between them. The reactants are written on the left hand side with a plus sign between them. That means these two are getting added. They may be 3, 400 also. Reactants may be any number. Products may also be any number. It's not that always a single product is formed. Sometimes 2 products, 3 products are also formed. Okay. Similarly, products are written on the right hand side with a plus sign between them. Arrowhead, what does it point towards? It points towards the where is the equilibrium. You will see some equations where you have a double-headed arrow. Okay, there is a right arrow and there is a left arrow. What does it mean then? It simply means that reaction is a reversible reaction. Reaction is possible in both the ways. Okay. For now, we'll understand what a simple chemical reaction is that two entities, that is a magnesium and oxygens, have been added to get magnesium oxide, which is the product. So magnesium and oxygen are reactants, magnesium oxide is the product. Okay, arrow shows the direction of the reaction. Now writing a chemical reaction equation. So how do I write a chemical equation? We saw the word equation form, that is that. Now actually symbolically how will you write it? So is there any other shorter way for representing a chemical equation? Chemical equations can be made more concise and useful if we use chemical formulae instead of words. So a chemical equation represents a chemical reaction. If you recall formulae of magnesium, oxygen and magnesium oxide, the above word equation can be written as what? Mg plus O2 gives rise to MgO. So what is Mg here? Mg is just a shortcut or a symbol for magnesium. O2, everyone knows that it represents oxygen. MgO, what is MgO? It is magnesium oxide. So is it not become much simpler to just tell that Mg plus O2 has given MgO instead of telling magnesium plus oxygen has given you magnesium oxide? Okay. So that's why the symbols were introduced to make things look simpler. Count and compare the number of atoms of each element on the LHS and the RHS of the arrow. Is the number of atoms of each element the same on the both sides? If yes, the equation is balanced. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Such a chemical equation is called skeletal chemical equation for a reaction. Equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. So now we'll try to understand a point that what is a skeletal equation. Skeletal equation is basically a raw equation, an unbalanced equation. If you see here, Mg plus O2 gives rise to MgO. Magnesium is balanced. There is a one atom of magnesium on the LHS. There is a one atom of magnesium on the RHS. Very much, pretty much balanced. But if you come to oxygen, there are two oxygens on the left hand side, but only a one oxygen on the right hand side. Then how is the law of conservation of mass valid here? It is completely failure here. But we should understand that whenever any chemical reaction is taking place, it should not violate the law of conservation of mass. So here we have to balance the equation. How do you balance this equation? Try to do it. Put a 2 in front of magnesium, put a 2 in front of MgO. It is balanced. 2Mg plus O2 gives rise to 2MgO. That is a balanced chemical equation where you have two magnesium atoms, two oxygen atoms on the LHS, and two magnesium atoms and two oxygen atoms on the RHS. Okay. So our very next topic is law balanced chemical equation. So recall the law of conservation of mass that you studied in class 9. Mass can neither be created nor be destroyed in a chemical reaction. That is, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. So mass should not be changed. If I am taking 1 kg of magnesium and 1 kg of oxygen, then I should get 2 kg of magnesium oxide. That is fixed. Mass cannot be created, cannot be destroyed. Okay. So we will see how we are doing a balance. So in other words, the number of atoms of each element remain the same before and after a chemical reaction. Hence, we need to do a balancing of this chemical equation, which we saw in 1.2. So you saw that 1.2 was not balanced. Anyways, we'll move to another equation. Zinc plus sulfuric acid gives rise to zinc sulfate plus hydrogen. Zn plus H2SO4 gives ZnSO4 plus H2. If you see zinc atom on the left hand side, 1, right hand side also 1. Sulfur is 1s, right hand also 1. Oxygens are 4, right hand also 4. Two hydrogens, pretty much balanced. You can go through the table also. It is the number of atoms of the reactants on the left hand side and number of atoms of the product on the right hand side, both are equal. So it is a balance. Come back to next equation now. Fe plus H2O gives rise to ferric oxide, Fe3O4 hydrogen. Yeah, this equation is not balanced. Clearly, if you see the number of atoms of Fe on the left side is 1, but Fe, that is iron on the right side, is 3. Oxygen on left hand side is 1, but oxygen on right side is 4. Hydrogen is balanced, but iron and oxygen are not balanced. So what are the steps we need to know when we are balancing a chemical equation? We'll go through that. So step 1, to balance a chemical equation, first draw boxes around each formula. Okay. Do not change anything inside the box while balancing the equation. So we have drawn boxes as you can see from the equation 1.5. Next step, list the number of atoms on different elements present in the unbalanced equation. Iron, how many atoms are there? 1 atom. We have listed it in the LHS. In the RHS, iron is having 3 atoms. So we have written 3 in the first row. Second, we are coming to hydrogen. 2 atoms of hydrogen are there in the reactant side. 2 atoms are there on the product side. Pretty much balanced. Oxygen, there is 1 atom of oxygen in the reactant, but there are 4 atoms of oxygen in the product. So it is unbalanced. So now, shall I first balance iron or shall I first balance oxygen? This is my first dilemma that comes to my mind. So we'll read step 3 for that. It is often convenient to start balancing with a compound that contains the maximum number of atoms. It may be a reactant or a product. In that compound, select the element which has the maximum number of atoms. Using this criteria. See, what is our criteria? First, select a compound which has maximum number of atoms. Iron, how many compounds in the LHS? 1. Water, H2O, 3. Fe3O4, how many atoms? 7. Hydrogen, 2. What are we going to select? Fe3O4. Now, in that Fe3O4, what should I select? He is telling in that Fe3O4, you select an element which has a maximum number. What is the maximum number here? Oxygen. So, first we will try to balance the oxygen now. Are you getting the point how we have selected? First, shortlist the compound which is having the maximum number of atoms. After that, in that also take the element which has the maximum number. Yeah. So if you see initially in water, in H2O, there is only one oxygen, but in Fe3O4, there are 4 oxygen. So I will put a 4 in front of the H2O that I have done in my step 3. Fe plus 4H2O gives rise to Fe3O4 plus H2. But if you see, immediately when I have put 4H2O, the hydrogen which was balanced previously, it is now unbalanced. Hydrogen has become unbalanced. There are 8 hydrogens on the LHS, but there are 2 hydrogens on the RHS. So we will see how to balance this next, iron and hydrogen. So what are we going to do? First thing, we'll proceed to balance hydrogen because there is 4H2, that means 8 hydrogen atoms. I will put a 4 on the RHS side. So you can see the equation 1.7, which is a partly balanced equation. Still, the iron is not balanced. You see, Fe plus 4H2O gives rise to Fe3O4 plus 4H2. Now, clearly, I can see that the number of atoms of iron on the left-hand side is, but we have 3 atoms of iron on the right-hand side. So I will put a 3 in front of the iron on the left-hand side. So my final equation will come out as 3Fe plus 4H2O gives rise to Fe3O4 plus 4H2. So then we'll read the last para once. The number of atoms of elements on both sides are equal. This equation is now balanced. This method of balance is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Okay. There is one more step to it. What is that? Writing the symbols of the physical state. What is the state of iron? What is the state of water? What is the state of hydrogen? We have to write it. Exam also we have to write it, otherwise we are going to lose some marks. So writing symbols of physical state, carefully examine the above balanced equation. Does this equation tell us anything about the physical state of each reactant and product? No information has been given in this equation about their physical state. To make the chemical equation more informative, the physical states of the reactions and products are mentioned along with the chemical formulae. The gaseous, the liquid, aqueous, and solid states of the reactants and products are represented by. How will you represent a gaseous form? With a G. L is for a liquid. Aqueous form is AQ. What is the difference between liquid and aqueous? Aqueous means it is dissolved in water. Liquid means it is a liquid form. That means it has been converted from solid to liquid. Okay. Iron liquid is different from iron aqueous solution. Iron aqueous solution means iron will be dissolved in water. Okay. And solid state respectively. The word aqueous is written if the reactant or product is present as a solution is water. So if you see here, 3Fe. Fe is written as a solid there. That means iron in solid form is used. Water in a gaseous form is used. That means basically a steam. Fe3O4 is going to form in solid form, and hydrogen is going to evolve in gaseous form. Okay. Note that the symbol G is used with H2O to indicate that in the reaction, water is used in the form of steam. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Okay. So generally, we don't include them till there is a need to specify them. Mandatorily, if at all chemical equation has been asked as a question, then you need to specify it. Otherwise, in some other reaction, if you are they are just asking you to do some reaction balancing or there you can just specify the number, that's it. No need to specify the state. Okay. Sometimes the reaction conditions such as temperature, pressure, catalyst for the reaction are indicated above and below the arrow in the equation. For example, carbon monoxide in gaseous form plus 2H2 in gaseous form in a pressure of 340 atmosphere will give you methanol, CH3OH. Okay. And then we have 6CO2. What is this reaction? This reaction is a very, very important reaction on which the entire life form on Earth is dependent. That is photosynthesis reaction. 6CO2 plus 12H2O in the presence of sunlight and chlorophyll are given to give you glucose plus oxygen plus water. The formula for glucose is C6H12O6 and it is balanced here. Very, very important reaction. This is known as a photosynthesis reaction. Okay. Now we have some in-text questions which we'll be doing along with the exercise. Let us continue with this. Now we'll next move on to the types of a chemical reaction. So we have learned in class 9 that during a chemical reaction, atoms of one element do not change into those of another element. Oxygen atom will not become into a nitrogen atom. It is not possible. Okay. Nor do atoms disappear from the mixture or appear from elsewhere. Actually, chemical interaction involves the breaking and making of bonds between atoms to produce new substances. See here, only thing is that oxygen is there and magnesium is there. They are combining, both the atoms are combining to form magnesium oxide, a new product, new compound. But it is not that oxygen has changed to magnesium oxide, no, or magnesium has changed to magnesium oxide, no. They are combining, they are making a bond or breaking a bond. What is a chemical reaction? Make the bond, break the bond. This is the chemical reaction. Okay. Then we have types, combination reaction, displacement reactions, double displacement reactions, all that go here to see. Yeah. So coming to the first type, that is a combination reaction, a very simpler one in fact. Take a small amount of calcium oxide or quicklime, CaO, and slowly add some water to it. Touch the beaker as shown in figure. Do you feel any change in temperature? Of course you will feel it. Why? Why there is a heat evolved in this reaction? So the reaction in which heat is evolved, what do we call it? Okay. And the reaction in which heat is absorbed, what do we call it? So reactions are also classified based on heat. We are going to learn that also. Okay, but this is different types of classification which we have. We have here combination reaction. CaO plus H2O gives rise to CaOH taken twice plus heat. What is this calcium hydroxide? It is also called as a flaked lime. Okay. So here if you see that heat is evolved in the reaction. So in this reaction, calcium oxide and water combine to form a single product, calcium hydroxide. Such a reaction is called a combination reaction. What is a combination reaction? In which single product is formed from two or more reactants. Reactants may be 3, 4, 5, we don't care. Product should be one. Then it is a combination product. They are combining combination product. One more example, C plus O2 gives CO2. Okay. You can go for large number of examples for this. Okay. So we'll discuss some more reactions. Okay. Let us discuss some more examples of combination reactions. Burning of coal. C plus O2 gives CO2. So when you are burning coal, it is a combination reaction. Of course, a lot or amount of heat is evolved in this. So it is an exothermic reaction. So next, formation of water. H2 plus O2 gives rise to 2H2. This, if you see, hydrogen in gaseous form and water in gaseous form have combined to form water in liquid form. Okay. Such a reaction where there is two reactants combined to form a single product is called a combination reaction. So in a simple language, we say two or more substances combined to form single product is a combination reaction. In activity 1.4, we observed that large amount of heat is involved, which makes the reaction warm. Reactions in which heat is released along with formation of products is called exothermic reaction. Let us read it again. Reaction in which heat is evolved along with formation of products is called what? Exothermic reaction. Then what is an endothermic reaction? Reaction in which heat is absorbed. Endothermic. Endo, it is coming inside. Exo, it is going outside. Okay? So burning of natural gas, what kind of reaction? If you are burning a natural gas, what are we getting? Heat. What is a natural gas? First of all, methane. CH4 plus O2 gives rise to CO2 plus H2O. Do you think respiration is an exothermic process? Why? Do you feel that respiration is an exothermic reaction? Yes. Why? Because in that energy or heat is evolved. Heat is a form of energy. Heat is a form of energy. What are the other forms of energy? Light, sound. These are other forms of energy. Okay. We all know that we need energy to stay alive. We get this energy from the food we eat. During digestion, food is broken down into simple substances. For example, rice, potatoes, and bread contains carbohydrates. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is called respiration. Do you find any similarity between a photosynthesis and a respiration process? Don't you think just changing this reaction, LHS you make the RHS, RHS you make the LHS, don't you think it is very similar to a photosynthesis? Okay. So what is happening? Plants perform photosynthesis, form the glucose, and not only plants, plants also do respiration also. And animals, they perform respiration. What is respiration? Don't confuse respiration with breathing. What is breathing? Breathing in is taking in of oxygen and releasing of carbon dioxide is called breathing. That is a different thing scenario altogether. What is respiration? Respiration is breaking down of glucose into carbon dioxide and water in order to release energy. So what is happening when I am taking glucose? I am breathing in oxygen that is going into my lungs. Then there is a respiration process happening, that is the glucose is being broken down. Then I am getting the energy. You will see that this energy is in the form of ATP molecule. What is ATP molecule? Adenosine triphosphate molecule. So this adenosine triphosphate molecules is deposited in the blood, which will supply this energy into all the cells of my body. Now, what will happen to the carbon dioxide that is released there? Are we not exhaling it carbon dioxide? Where is it coming from? How our body is producing carbon dioxide? Because of respiration process. That is the breakdown of. Okay, so it is a exothermic reaction. Then the decomposition of vegetable matter into compost is also an example of exothermic reaction. You know that bioenergy, if we deposit vegetable waste into a pit, compost, and you close it with the mud, after some time you will see that heat is revolved along with the evolution of methane gas. So that is kind of a exothermic reaction. Okay. Now we will come to the next type of reaction, that is a decomposition reaction. So we'll do a small activity in this. Take 2 grams ferrous sulfate crystals in a boiling tube. That is, you are dry boiling the tube. You are not using any water. You are dry boiling it. Note the color of the ferrous sulfate crystals. Heat the boiling tube over a flame of burner. Observe the color of the crystals after heating. We will see what has happened to the crystals. Have you noticed that? What was the color of ferrous sulfate? Green color. It has changed. You can also smell the characteristic odor of the burning sulfur. Okay, so what has happened in this reaction? If you see the reaction 1.19, ferrous sulfate, when it was heated, what are the products we got? Ferric oxide plus sulfur dioxide plus sulfur trioxide. So a single reactant has given more than one product. Previously, multiple reactants have given a single product. Here, single reactant is giving multiple products. So decomposition is exactly the opposite of which reaction? Combination reaction. Okay. So in this reaction, you can see that a single reactant breaks down into simpler product. This is a decomposition reaction. Ferrous sulfate crystals lose water when heated and the color of the crystal changes. It then decomposes to ferric oxide, Fe2O3, sulfur dioxide, and sulfur trioxide. Ferric oxide is a solid, while SO2 and SO3 are gases. Decomposition of calcium carbonate to calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quicklime. CaO is called as what? Lime or quicklime. It has many uses. What is one use? It is used in the manufacturing of cement. When a decomposition reaction is carried out by heating, it is called thermal decomposition reaction. Now, what are we doing is that in decomposition, there are some categories. In decomposition, what are the categories we are going to learn? First of all, you try to understand one thing, that no compound will break just like that. You need to supply some energy to that compound to break and give two or more products. What is happening in decomposition? A single compound is breaking down into two or more compounds, or maybe any element also, and it is giving some heat. It may take, it will not give, it will take some heat, or it may take some light, or it may take some electricity, some form of energy. So what form of energy can I give? I can give energy in the form of heat, I can give energy in the form of light, I can give energy in the form of electricity. So these kind of reactions have been classified in three different ways. How? The reaction in which heat is taken by a compound to break into two or more products is called what? Thermal decomposition reaction. An example is that when I burn calcium carbonate, basically I'm supplying the heat. It will turn into calcium oxide and carbon dioxide. Another example will directly go to the example. What is this? Lead nitrate, when I heated, I got lead oxide plus nitrogen dioxide plus oxygen. Okay. On the supply of heat, this reaction also will occur in the supply of heat. How will you observe that the gas is evolved? What is that gas? You will observe that brown fumes have come. For the brown fumes, these brown fumes are the fumes of nitrogen dioxide. Okay. Yeah. See one more activity. If you see, yeah, this activity, rather than reading the entire activity, we'll just try to understand what is happening. Basically, they have taken water, okay, in a jar, okay, in a container, and they are passing electricity through it. What are we doing? We have taken water in a jar and we are passing electricity through it. So when you pass electricity through water, what will happen is that water will break down into two things, two elements. What are the? Hydrogen and oxygen. Hydrogen will be deposited at the cathode, oxygen will be deposited at the anode. This is very important 1 mark question. In electrolysis of water, what is electrolysis of water? Whenever you are passing electricity through water, that is called electrolysis, means breaking of water. Lysis means breakdown. Breakdown of water with the use of electricity is called electrolysis. So in this reaction, they will ask you what is formed at the anode, what is formed at the cathode. Oxygen is formed at the anode, hydrogen is formed at the cathode. So this is called electrolysis reaction or electrical decomposition reaction. So we are done with thermal decomposition reaction, we are done with electrical decomposition reaction. Now what is the next reaction we have to learn? We have to learn the photolysis reaction. Photo means what? Light. We'll see one activity. So you are taking 2 grams of silver chloride in a china dish and you are keeping it in the sunlight. What will happen? So you will see that 2AgCl, the silver chloride will turn gray in sunlight. Why? Because of the, what is happening? Decomposition of silver chloride into silver and chlorine by light. Okay. So silver metal is being formed. Silver chloride. Same reaction you can do with silver bromide also. You will get silver plus bromine. So the above reactions are used in black and white photography. So these two reactions are being used in black and white photography. So what form of energy is this? Light energy, solar energy. So this, we have seen that decomposition reactions require energy either in the form of heat, light, or electricity for breaking down the reactants. Reaction in which energy is absorbed are known as endothermic reaction. So we have two more classification based on energy requirements or heat requirements. If energy is being taken to perform the reaction, endothermic. If energy is given out in the reaction, it is exothermic. As simple as such. Yeah. Now we will move to the third type of reaction, that is the displacement reaction. So we'll read an activity for this reaction. So take 3 nails and clean them by rubbing with a sandpaper. Take 2 test tubes marked as A and B. In each test tube, take about 10 ml of copper sulfate solution. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution for about 20 minutes. Okay. After 20 minutes, take out the iron nails from the copper sulfate solution. Compare the intensity of the blue color of the copper sulfate in the test tubes. Also compare the color of iron nails dipped in the copper sulfate solution with the one which was kept aside. So what has happened? We'll see here. See the iron nail, and you see the iron nail kept out from the copper sulfate solution. Is it not almost brown color? Okay. So what has happened to that copper iron nail we are going to see now. Why does iron nail become brownish in color? And the blue color of the copper solution, if you see, it has completely faded in the test tube B. The copper sulfate solution, which was blue, is no longer blue. It is faded. So what has happened? We are going to see here. So basically what has happened here? Fe, that is iron in solid form, was dissolved in copper sulfate in aqueous form. You got iron sulfate plus copper. So in this reaction, what has happened is that iron has displaced the copper from its solution. Iron has displaced copper from its solution. What solution? Copper sulfate solution. So this kind of reaction is known as displacement reaction. Displace means what? You are taking the place of someone else. You are going and sitting in the place of someone else. Iron has removed copper from its seat and it has gone and sat down on that seat. Okay. So we'll see some other examples of zinc displacement reactions. Zinc plus copper sulfate gives you zinc sulfate plus copper. Lead plus copper chloride gives you lead chloride plus copper. Zinc and lead are more reactive than copper. They displace copper from its compounds. Now, there is one very important thing to be noted down in this displacement reaction. We have written that zinc plus copper sulfate gives you zinc sulfate plus copper. That is equation 1.25. We are very clear that zinc has displaced copper from its solution. Can copper displace zinc from its reaction? If I write Cu plus ZnSO4, will it give me Cu plus ZnSO4? Will it give me CuSO4 plus Zn? Basically, I'm asking, will the reaction occur in the reverse way? 1.25. If the LHS becomes the RHS and RHS becomes the LHS, is it still true? Answer is no. Why? Because copper cannot displace zinc from its solution because copper is less reactive than zinc. So we have a reactivity series which we should learn to understand which element or which metal can displace which metal from its solution. Okay, we have to basically by heart that reactivity series. Okay. Now we have the next type of reaction. So that is called the. So how many we have learned till now? Three. What are that? Combination reaction, decomposition reaction, and displacement reaction. Now we will learn the double displacement reaction. So take 3 ml of sodium sulfate in a test tube. Another test tube, take barium chloride. Sodium sulfate and barium chloride, we are adding them. And we are seeing what is going to happen. So sodium sulfate plus barium chloride, what is happening? If you see Na2SO4 plus BaCl2 is giving you BaSO4 plus NaCl. So if you see, there is an exchange of ions in this. Sulfate ion, which was with sulfur, sodium, has gone to barium. The chloride ion, which was with barium, has gone to sodium. There is an exchange of ions in this reaction. Such a reaction is called double displacement reaction. And in this reaction, everything is in aqueous form. But there is one solid form that is being formed. And it will deposit at the bottom of the test tube. That is the barium sulfate. So such a solid, insoluble substance which has been formed is called what? Precipitate. Precipitate. And this reaction is also called as precipitation reaction. Okay. This reaction is also called a precipitation reaction. So any reaction that can produce a precipitate can be called as a precipitation reaction. So what causes this? The white precipitate of barium sulfate is formed by the reaction of the sulfate and barium ions. The other product formed is sodium chloride, which remains in the solution. Such reaction in which there is an exchange of ions between the reactants are called double displacement reaction. Okay. Yeah. Now we will go to the next type of reactions, that is oxidation reactions and reduction reaction. So we'll see what is an oxidation. See, basic definition of oxidation will be like addition of oxygen is called oxidation. Removal of oxygen is called reduction. That is basic, but however, we'll learn better definition for that. Okay. So activity, heat a china dish contain 1 gram of copper. So heating means what? You are heating it in the presence of oxygen. Copper plus oxygen will give you what? Copper oxide. The surface of copper powder becomes coated with black copper oxide. So the brown copper is becoming black. Why? Because of the formation of copper oxide. Why has this black substance formed? This is because oxygen is added to the copper and copper oxide is formed. So this is what clear cut example for oxidation reaction. Cu plus O2 gives rise to CuO. Suppose if I had hydrogen or I may remove oxygen, then it is called what? Reduction reaction. So what is a reduction reaction? Removal of oxygen or addition of hydrogen. What is an oxidation reaction? Addition of oxygen or removal of hydrogen. Okay. Next, we'll see an example for another reaction, reduction reaction. If hydrogen gas is passed over the heated material, copper oxide, the black coating on the surface turns brown. Now we have reversed that reaction. Copper oxide plus hydrogen is giving you copper back plus water. So this reaction is what? Reduction reaction. So if a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. So in the reaction 1.29, if you see, both the things are happening. Copper oxide, what is happening? It is becoming copper. CuO is becoming Cu. That means it has lost oxygen. Lost oxygen means which kind of reaction is it? Reduced. Copper oxide has been reduced to copper. But if you see hydrogen, H2 has become H2O. It has gained oxygen. Hydrogen has been oxidized to water. Copper oxide has been reduced to copper. So it is a what kind of reaction? It is a redox reaction. It is a redox reaction. Okay. Where both oxidation and reduction are happening simultaneously. Then we'll see some other examples for a redox reaction. Zinc oxide plus carbon gives you zinc plus carbon monoxide. So what has happened here? Zinc oxide has been reduced to zinc. Oxygen has been removed from it. Carbon has been changed to carbon monoxide. It has been oxidized to carbon monoxide. In the next reaction, what is happening? HCl, okay, is oxidized to what? MnCl2. That means it has lost its hydrogen. Okay. So what can you say? Hydrochloric acid has changed to MnCl2. So chlorine has lost its hydrogen. It is oxidized. What has happened to MnO2? It has lost its oxygen. It has become manganese chloride. So it has got reduced basically. It has got reduced. Okay. In reaction, carbon is oxidized to CO and ZnO is reduced to Zn. In this reaction, HCl is oxidized to Cl2, whereas MnO2 is reduced to MnCl2. From the above examples, we can say that if a substance gains oxygen or loses hydrogen, it is oxidized. If a substance loses oxygen or gains hydrogen, it is reduced. Yeah. Now we'll see last two topics. That is what is corrosion and what is transitivity. So this is very simple corrosion you might have observed in your everyday life, that iron is getting rusted, silver is getting blackened, and there is, if you copper, if you see, there is a green coating. All these are basically because of the spoil sport that is being placed by oxygen. Okay, oxygen is playing the spoil sport here, and because of this rusting and everything, there is a crores of loss to our buildings, bridges, ships, etc. Whatever is of metal, that is being rusted. Okay, or we have some techniques to prevent rusting also. So you must have observed that iron articles are shiny when new, but get coated with a reddish brown powder when left for some time. This process is commonly known as rusting of iron. Some other metals also get tarnished in this manner. Have you noticed the color of the coating formed on copper and silver? When a metal is attacked by substances around it, such as moisture or acids, it is said to corrode. So moisture is what? Water, okay, in air, that is going to affect the metals. Okay, acids are going to affect the metals. Then oxygen is going to affect the metals. For example, black coating on silver is corrosion. Green coating on copper is corrosion. Corrosion is causing a lot of damage to our cars, bridges, iron railings, ships, and to objects which are made of metal, especially iron. Corrosion of iron is a serious problem. Every year, an enormous amount of money is spent to replace the damaged iron. Okay, we'll see how to prevent it later on. Basically, you can galvanize it with zinc. We have some other techniques also. Iron, you can do galvanization process, but you can coat it with zinc to prevent rusting. Then what is rancidity? Have you ever tested or smelled the fat or oil containing food materials left for a long time? Such a bad smell it gives. Why? What is happening to that food or the oil in it? When fats and oils are oxidized, they become rancid and their smell and taste changes. Usually, substances which prevent oxidants, antioxidants, what are the substances which prevent oxidation are called antioxidants, are added to help foods containing fats and oil from preventing oxidation. Keeping foods in airtight containers also helps to slow down the oxidation process. Do you know that chips manufacturer usually flush bags of chips with gas such as nitrogen to prevent the chips from getting oxidized? So if I buy a Lay's packet today, you will see that it is fluffy in nature. You think why he is putting so much of air in it? It is not air, basically it is nitrogen. Why is it putting nitrogen? So he doesn't want that chips to get oxidized. Okay, as simple as such. So we are going to prevent it from getting rancid. So we are done with the chapter. And coming to the questions, in-text questions, I mean, and the exercise will be discussed in our next video. Thank you, students. Keep learning. Thank you.